James Webb saw light escaping from an age when light should have been trapped. The early universe was not clear. It was foggy, filled with neutral hydrogen that could block the kind of light young galaxies were trying to release. But Webb found a galaxy so early and so strange that its light seems to have punched through the cosmic fog. That means something powerful was happening there. Maybe stars were burning harder. Maybe the galaxy had cleared a tunnel through the darkness. Maybe the universe became transparent faster than we thought. So the question is, what opened the first holes in the cosmic fog? This matters because Webb detected unexpected Lyman alpha light from Jade's GS Z13-1, a galaxy seen only about 330 million years after the Big Bang. NASA said the finding challenges researchers to explain how that light pierced the thick neutral hydrogen fog that filled the early universe at that time. If Webb is right, then this is not just about one ancient galaxy. It is about how the dark early universe became visible at all. The universe was not always transparent. That is the part most people miss. When we look up at the night sky, light feels free. Stars shine. Galaxies glow. Telescopes catch photons that have crossed billions of years. But in the early universe, light had enemies. One of them was hydrogen. A thick fog of neutral hydrogen filled space before the universe became fully transparent to ultraviolet light. And that fog should have blocked one of the most important signals young galaxies can produce, Lyman alpha emission. ESA describes Jade's GS Z13-1 as a galaxy seen when the universe was only about 330 million years old, yet showing a surprisingly clear Lyman alpha signature from a time when the surrounding cosmic fog should still have been difficult to pierce. That is why this discovery feels like Webb broke physics. It did not break the laws. It broke the expected timeline, because the simple picture says the early universe was still cloudy, still young, still wrapped in neutral gas, and still not ready to let that kind of light travel freely. But Webb saw it anyway. A signal from hydrogen, bright, clear, and ancient, was escaping from a galaxy so far away that its light began its journey before the universe was even 500 million years old. NASA says Webb discovered Jade's GS Z13-1 in images from the Jade survey, and the galaxy is observed as it existed just 330 million years after the Big Bang. Think about what that means. This was not a galaxy shining in a mature universe. This was not a galaxy glowing after billions of years of cosmic cleanup. This was a galaxy from the dawn, from the messy beginning, from the time when the first generations of stars were starting to change the universe around them. And somehow its light got out. That is the conflict. Lyman alpha light is powerful but fragile. It comes from hydrogen and can reveal young stars, hot gas, and intense radiation. But it is easily scattered or absorbed by neutral hydrogen, sitting between the galaxy and us. So, in an early universe still filled with neutral hydrogen, that signal should struggle to survive. It should be weakened, hidden, or erased. And yet Webb caught it. NASA's spectrum graphic for Jade's GS Z13-1 shows bright Lyman alpha emission, which is surprising because that emission should have been absorbed by the dense fog of neutral hydrogen that filled the early universe. That is the first real shock. The light did not just exist. It escaped. And for it to escape, something had to change the space around the galaxy. Maybe the galaxy was producing unusually intense radiation. Maybe its stars were hotter than expected. Maybe it contained an active black hole. Maybe nearby galaxies helped carve a bubble in the fog. Or maybe the first galaxies were more aggressive at changing the universe than our models assumed. The point is not that physics failed. The point is that the universe may have started clearing itself earlier, faster, or in stranger pockets than we expected. That is the consequence. Jade's GS Z13-1 is not just another distant red dot. It may be a beacon from the moment the universe began to become visible. A galaxy lighting a hole through the fog. A signal from the edge of the cosmic dark ages. A clue that the first sources of light were already fighting the darkness when the universe was still extremely young. And that changes the emotional weight of the discovery, because Webb did not just see an old galaxy. It saw light escaping from a universe that should have been trying to hide it. So the first revelation is this: Webb did not break physics. It caught physics happening earlier than expected. But the next question is even more dangerous. What inside that tiny, ancient galaxy was powerful enough to clear a path through the fog? To understand why this is so strange, imagine the early universe like a room full of smoke. A candle can burn inside it, but from far away, you may not see the flame. The smoke blocks it, scatters it, and hides it. Now imagine that one tiny flame somehow clears a bubble around itself. Suddenly, the light gets out. That is what Jade's GS Z13-1 may have done. It did not clear the whole universe. It did not end the cosmic dark ages by itself, but it may have carved out a small transparent region around its own light, a hole in the fog. Researchers reporting the Webb detection say the unexpected Lyman alpha emission suggests the galaxy was a strong producer and leaker of ionizing photons, possibly powered by massive, hot stars or an active galactic nucleus that created an early ionized region around it. That is where the mystery becomes sharper, because a normal young galaxy may not be enough. At 330 million years after the Big Bang, the universe had not had much time. Gas had to fall together. Stars had to form. Radiation had to pour out. That radiation had to escape the galaxy. Then it had to ionize enough, surrounding hydrogen, to let Lyman alpha light pass through. Every step is hard. Every step takes energy. Every step has to happen early. And Webb found evidence that it did. That is why scientists are paying attention. Not because one line of light destroys cosmology, but because one line of light can reveal a hidden engine. Maybe the galaxy was packed with very hot, massive stars. Stars unlike the calm image we have of the modern universe.